Morning, dear students. Hope you are doing good. As we are discussing treatment of water, how the water will be treated at large scale before it is being supplied to the public, we are discussing as part of our curriculum for the subject E1. See here in the diagram, sorry, in the pic or else in the image, you may have or else you may got an pictorial view of this water plant, water treatment works into your mind. See, all these are the different units. All these are the different units constructed in a sequential order through which water passes step by step and finally reach to the stage from where the water will be distributed to the public. The final stage, in the sense, pure water. So, and here first stage in the treatment means from the intakes, water enters into the treatment works. After the treatment, the water will be supplied to the public. This is then a view, a synoptical view of water plants, not water plants, water treatment works. As part of this water treatment, we have seen the first stage, plain sedimentation, followed by sedimentation with coagulation. We have seen. We are there, the topic filtration. The filtration, we are trying to remove bacteria, color, odor, and any other minerals which are exceedingly existed in that particular water batch, or else water that enters into the treatment works. See here in the previous step, we have seen what sedimentation process, we will remove all the settleable particles. But we may not remove entire or else all the particles, all unwanted particles through the sedimentation, but still there are the chance of existing the particles which may not settle under normal conditions on the bottom of water tanks, which may not settle in normal conditions on the bottom of the tanks. And also we have seen, for instance, 0.6 mm size particles, it takes 10 hours. For 0.02 mm particles, it takes 4 days, which are practically not possible every time to store water such a long period of time, especially when the water is in demand. In such cases, we are adding certain chemicals or else coagulants to remove all those unsettled particles. Because of the action of coagulants in the water, all the particles will come to contact into that chemical dose by name coagulant forms as in a flux on the surface of the water. That flux will remove by mechanical scrapers. Likewise, we can remove the unsettled particles, as we can remove the unsettled particles in normal sedimentation. See, we have seen the example and how we can find out the optimum coagulant dose that we must add to the waterworks for the action of coagulants, as for the efficient action of coagulants. We have seen, and this is the jar test container. You might have seen this container in your E-lab, I think so. We have in a lab, we have this equipment in our laboratory also. When you come to the lab, you may get full detail about this jar test container physically also. See our flocculation. Simply we are adding the dose what we found in the jar test to the water and allow to the pedal which is fixed on a bearing for 2 to 3 RPMs. By doing so, as I said, the flux will be settled on the surface of the water bodies. From there, it will be removed and the clean water will be sent through outlet. Aluminum sulfate is an example of coagulant. I have seen yesterday itself. Now we enter into the topic filtration. We are filtering. What we are filtering? Why we are filtering? Because the particles which may not remove by coagulant, by the action of coagulants, can be removed this filtration. Is there any possibility that coagulants may not remove? Is there any possibility of the situation, or is there any existence of situation where the coagulants may not remove complete particles? Yes. Even by adding coagulants, even in a coagulation process, still there is a chance of existing certain particles or certain undesirable substances in the water. They are nothing but bacteria, algae, and color-causing substances, taste, odor, and all. Taste, odor, and all. See here, by doing so, in this filtration, we can remove all the bacteria, all the unwanted particles like bacteria, algae, then color, odor, taste, to produce clear, sparkling water, or as to produce clean water. See what is happening in this filtration, we will discuss now. There are the following actions will take place in filtration. What are those following actions? The first one is mechanical stirring. Here, filtration in the sense, this filtration will be completed, the process will be completed with the help of the media which is prepared by sand and gravel. That is the reason the mechanical stirring, one of the action that may take place in filtration, when the water is being sent through the media like sand, the voids in between the sand granules plays vital role in this filtration. See here the first point, the suspended particles which are larger in size cannot pass through the voids between the sand granules. That means those voids are acting as filtering units. But When the suspended particles are large in size, the voids may not perform their task because the voids will be closed because of the suspended particles. Understand what I said? Did you understand what I said? When the water is passing through the voids of the sand, the suspended particles will be settled on the sand, top of the sand, it will be removed. When the process going on for a period of time, automatically the voids will be closed whenever the substances sizes are more than the size of voids. Understand? Next one. While the fine particles passing through the voids, they come in contact with the surface of the sand voids and adhere, due to which the size of the voids reduce gradually. One more phenomena, or else one more action takes place. Apart from that blocking of voids by large substances than the size of voids, the one more case is, while the water is passing through the voids for a period of time, the small substances may adhere to the walls of voids. After a period of time, the voids can be blocked because the substances are adhering inside the voids. Whereas in the first case, the largest substances are striking on the voids on above surface, above a layer, or else on the top of the sand itself. So the action will be reduced or may stop. But here in these voids, sometimes while water is passing through these voids, after a period of time, the small organic materials in that wastewater or else in that water, filtering water, will adhere to the voids of the sand granules. After a period of time, they may cause the blockage of filter. In such cases, mechanical stirring is needed to unblock those voids. Stirring, understand, stirring. Mechanical stirring is needed to remove those voids with the help of scrapers. How can we remove those voids? Simply we are just stirring the sand media by the help of scraper, so the clogs will be removed between the voids of the sand granules. This is the action which may observe in filtration. Next one is sedimentation. See, as the voids are blocked, what is sedimentation? We are simply allowing water for a period of time without any disturbance. All the weighted particles will settle on the bottom. Am I right? Similarly, as the voids are blocked on their bottom, the particles will be, or else water will be stored within the voids. And they are acting, those voids are acting as settling basins for sediments. Am I right? This is then a passing media void. The void is closed at its bottom. The water reach and water is passing. Water is supposed to pass through the voids, but the voids are blocked. And the void is filled up with water and acting as a temporarily settling basins for sediments. Likewise, the voids are acting as temporary settling basins for sediments. This is also one of the action which may observe in filtering. And third one is bacterial action. See, as the wastewater is going through the voids, they may be blocked because of the organic material of wastewater. We have seen in the mechanical stirring itself, The large particles may not pass through the voids and settles as in a layer on the top of the sand layer. And small particles, next case, small particles are passing through the voids as they may adhere to the walls of the voids. They may cause also blockage of voids after a period of time where the water passes through those voids. What I'm speaking is here. Listen carefully. The wastewater is going through the voids, they may be blocked. Why? Because of organic material of wastewater. The voids may be blocked. How? What is void here? Void is acting as a filtering media, or else void means the space between the sand granules is a void. Those voids will be blocked because of the waste material that is being sent through the media. In such cases, the organic material attracts bacteria and changes the characteristics of water. As the water passes to the other side of the media, which clearly gives the change of filter media is required. See here, which gives, I wrote over there, see, which gives the information to replace the sand bed for smooth functioning of sand bed. Next one is electrolyting action. One more action in filtration we may observe electrolytic action. What is this electrolytic action here? As the wastewater is passing through the voids, sand granules, or as the surface of the sand granules becomes smooth and acquires electrolytic charge, which is exactly opposite to the electrolytic change of ionized material of wastewater. One more time. As the water is passing through the voids, the surface of the voids may get an electrolytic charge, which is directly opposite to the ionized electric charge of the wastewater that is being pumped through those voids. But this electrolytic action will be neutral. After a period of time, the granule surface may lose the tendency of electrolytic action, which can be renewed by washing the sand. After a period of time, the surface of the voids becomes smooth and loses its electrolytic action, which gives the meaning, which gives the information of changing, which gives the information of need of changing sand bed. Understand? The electrolytic action may lose because of the continuous pumping of water due to the smoothness. As the void's surface becomes smooth, they lost the tendency of electrolytic action, which clearly speaks to us change of filter bed is mandate. Understand? See here, what are the actions we may observe in this filtration? 4 steps: mechanical stirring, sedimentation, bacteriological action, electrolytic action. Now, there are 2 types of filters in wastewater treatment, and they are as follows. How and what are the techniques for this filtering? There are 2 processes, or else there are 2 procedures, or else there are 2 methods for filtering water. Why we are filtering water? Simply to remove bacteria, color, odor, taste, and any other impurities when they are existed beyond their permissible levels. What are those? 2 filters. One is slow sand filter, another one is rapid sand filters. What is this slow sand filter? What is this slow sand filter? What is this rapid sand filters? We'll discuss. What is this slow sand filter? What is this rapid sand filter? We'll discuss in next class. If you have any doubts, you please contact me in the domain, whatever you feel convenient. Here in the filtration, basically this filtration is adopted to remove the impurities which are unable to remove in the previous steps like sedimentation and sedimentation with coagulation. Because of those reasons, or is because of unable to remove the impurities like bacteria, color, algae, we will go through this step, this filtration step, to get the cleanness of water. Thank you. We'll meet in next class with continuation.